welcome to True Projects. In this video, we are going to explain about a project titled Fusion of Multi-Intensity Image for Deep Learning Based Human and Face Detection. The intricacies posed by varying environmental light in nighttime video surveillance are examined, presenting the challenges in detecting the intruders at a distance, low lighting, and discerning the nearby objects in the presence of intense illumination, confronting the dual issue of underexposure and overexposure. A multi-intensity IR illuminator emerges as a solution, offering the cyclically modulated illumination level. This innovation gives rise to the database encompassing of dynamic sequences of the video capturing the diverse indoor and outdoor scenarios with the fluctuating brightness. The primary objective centers on benchmarking the contemporary object detection techniques through the M13 dataset while introducing a novel fusion approach to enhance the object detection performance across the distant illumination intensity. As the technology advances, this project aims to refine the nighttime surveillance strategy, ensuring the heightened precision and efficacy and the object recognition under varying lighting conditions. This study delves into rectifying the issues encountered in the nighttime surveillance setups, such as misdetecting the distant entities and overexposing the nearby objects due to the imbalanced illumination level. To address this challenge, we introduced this dataset curated using the multi-intensity IR illumination, serving as a definitive benchmark for the contemporary object detection methodology. Extensive annotation accompanied the M13 dataset, enabling a comprehensive evaluation of the prominent object detection model, including SSD, YOLO, faster RCNN, and the mass RCNN. Our analysis encompassed the efficacy of these models across the varying illumination intensities, effectively establishing a novel benchmark for both the face and object detection. Catering to a broad spectrum of distances, this initiative strives to advance the nighttime surveillance technology, refining the accuracy and the versatility of detecting the mechanisms across the diverse lighting scenarios. And these are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7 on Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. In this step, the Python libraries are imported that were frameworks and the modules that are essential for the various stages of the data processing, image analysis, model construction, and the Flask integration. And the next one is exploring the dataset. In-depth exploration of the dataset is undertaken to comprehend its structure, attribute, and nonsense. This preliminary analysis informs the subsequent data processing and the model development decision. And the next one is image processing. It employed to enhance the quality, clarity, and the suitability of the input images for subsequent deep learning analysis. And the next one is loading the pre-trained model. Pre-training models such as YOLO v5 is loaded into the project framework, serving as a foundation for the human and the face detection. And the next step is data augmentation. Data augmentation strategies are implemented to expand the diversity and the quantity of the training dataset, enhancing the model's ability to generalize and detect the objects more effectively. And the next step is of processing the data based on YOLO v5 model. The dataset is processed according to the YOLO v5 model's requirements, ensuring the compatibility and optimal performance during the training and the inference. And the next step is building the model. Various machine learning and deep learning models are built, and the first one is YOLO v5. Its short form is of You Only Look Once version 5. It's a state-of-art object detection architecture known for its speed and accuracy. It employs a single deep neural network to simultaneously predict the bounding box and the class probability for the multiple objects in an image. In this project, it is adopted to perform the human and the face detection, leveraging its real-time capability to efficiently identify and localize these entities. And the second one is YOLO VI. As a potential evolution of YOLO architecture aiming to enhance detection and accuracy, and it builds upon the foundation of YOLO. And in this context, YOLO VI is explored as an alternative model for the human and the face detection. And the next one is YOLO V3. It's an earlier iteration of the YOLO family. It's renowned for its competitive accuracy and efficiency. It employs a multi-scale detection approach and utilizes the anchor box to predict the object bounding box and the class probability. And the next one is Mark RCNN. It's a prominent instance segmentation model extending the faster RCNN architecture to include the pixel level segmentation. It excels in providing the detailed mask for the object instance within an image. In the context of human and the face detection, it can be employed not only to identify these entities but also accurately segment their region too. And the next one is faster RCNN. It is widely adopted object detection framework that introduced the region proposal network for efficient region proposal generation. It offers the accurate and the fine-grained localization of objects, and in this project, the faster RCNN is considered for its capabilities in detecting the humans and the faces. And the next one is SSD. Single shot multi-box detector is recognized for its real-time object detection capability, efficiently predicting the object class and the bounding box coordinate in a single pass. It excels in the speed while maintaining the competitive accuracy, and this project is explored as a potential solution for the human and the face detection. And the next step is user gives the input as image. A user-friendly Flask interface allows the user to input the image for the human and the face detection. And the next step is the given input is pre-processed and when trained with the model used for detecting. User-provided images undergo the pre-processing including normalization, resizing, and formatting, aligning them with the model's input requirement. The next step is the segmented each object and put the bounding box. Detected object, namely humans and of the face, is to be segmented and the bounding box are placed around them, facilitating the clear visualization and the identified entities. And the next one is final outcome is displayed. The model's outcome, including the detected human and the faces with the bounding boxes, are displayed to the user through the Flask interface, contributing to the informed decision making and enhancing the human and the face detection capability in the diverse scenario. And the execution of the project. To execute the project, first we need to open the code folder, and this is the code folder containing of various files within it, and the sample folder containing of the images that will be used to test the performance of the model, and the static folder containing of the various folders like of CSS, images, fonts, JavaScript, and upload folders within it. And the template folder typically include the HTML documents of about, home, index, notebook, sign-in, and sign-up pages within it. And the YOLO V5 and YOLO V8 folder contain the algorithms of the V8 and V5, and the app is an py file which contain the algorithm information and is loaded into the project code as of Python and handle the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the notebook is an IPYNB file which contains the combination of code and graph output in all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appeared to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command that is cd space and paste this code folder path. By this it will change the code folder path to the current directory. And then write a command that is python space app.py. By using this command, it will change the It will execute the Python script and perform the runtime check for any syntax errors or the logical issues within it. And then click on the enter button. After running this app.py file, the Flash framework will host the application locally at the default address like this. We need to copy this local link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. And copying this link and pasting it on web browser. And then click on the enter button. Here we redirect it to this page containing of some information about it, and then click on the sign up button. Here it will redirect to the sign up page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect to the sign in page containing of username and password as of admin, and then click on the submit button. Here it will redirect it to this page containing of the choose file and upload buttons, and then click on the choose file button. Here it will redirect it to this folder containing of various images within it, and then let's select one and then click on the upload button. And here it redirected with an bounding box and predicted as human width of 0.53, and then click on the back button and the refresh button. Here we can choose the another file by clicking on the choose file button. I'm selecting the another image and then click on open button, and then click on the upload button. Here it predicted width of human of 0.62 and with face of 0.56. In this way we can detect the human and face by using the various deep learning models. And in conclusion, this work evaluates the state-of-art human face, and the detectors report their performance on existing multi-intensity IR illumination dataset with complete annotations also established for the dataset. To that end, a baseline approach is proposed, but is based on the pre-trained CNN detectors, a recently proposed tracker, and a simple fusion scheme to make the advantage of complementary effects among different illumination intensities.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.